right, I'm going to put an example problem. I recommend studying this. So I will say, I don't know. Okay, 80% of adults own a cell phone. Let's say that. Or we'll say, I don't know. Adults own a smartphone. I don't know if that's correct. Okay. I'm just making up statistics. All right. 80% of adults own a smartphone. We take a random sample of 95 people. Okay. Only 70%. 70. Yeah. We'll say only 72%. Okay, so maybe not. We won't say people. We'll say take a random sample of 95. Who knows? Huh? No. What's a group of people? All right, we'll say 95 teachers. Okay, only 72% of the teachers have smartphones. All right. Is this evidence that the proportion of smartphone users for teachers is less than 80%? Okay, that's my question. All right. So, take a few minutes. See if you can come up with the hypotheses. Figure out your standard error. Figure out your z-score. And figure out your p-value, which is the area in the tail or tails. Okay? And what is your conclusion? Okay. Well, at least see if you can come up with these things. Alright, so see if you can come up with these four, and we'll talk about the p-value and the conclusion together. I guess we'll talk about everything together. Huh? 6 parts, 1 question. We did this twice already. You guys have everything you need. Alright, a common mistake I'm seeing, okay? I'll give you the first part. In your hypotheses, you want to use the proportion from your population. The last question says, is this evidence that the proportion of smartphone users for teachers is less than 80%? So your hypotheses should use 80%, okay? So we'll do this. Our null hypothesis is what? P equals 0.80, and my alternative, P is less than 0.80, okay? Good. So use that, see if you can keep going. Alright. I'm just walking around, just checking on you guys. So don't use that. Use what's in the population of your hypothesis.
Oh no! No.
I thought you did it. That's my answer. 4, 0. Yeah. But what I'm saying here, you're getting a minus 1.
No, but I think I got that wrong.
Are you getting the Z4 minus?
Alright, okay, so I walked around and it looks like a lot of you guys are doing well. Some of you, I think, have made some mistakes. Alright, our standard error, P times 1 minus P over N. So I get the square root of 0.8, 1 minus 0.8 divided by 95. When I do that, I get 0.0410. Right? Z-score.
Oh, you wouldn't round that up to 1?
Yeah, 0.041, that's fine. It's the same, whether there's an extra 0 or not. Okay, so my Z is going to be 0.72 minus 0.80 divided by 0.041. Okay, and I get negative 1.95, is that right?
Yes.
Okay, so I looked that up in my table almost, huh? 0.0256. So my tail area is 0.0256. Okay. My alternative hypothesis has a less than. Okay. It doesn't have a not equal sign. So you only double it if you have a not equal. Otherwise, leave it in as your tail. Okay. So my p-value equals 0.0256. Right.
So the tail and the p-value are
In our case, the tail is and the p-value are the same, okay? Tail and p-value are the same. Tail equals p-value when the alternative has less than or greater than, okay? You only double it when you have a not equal sign. My conclusion, okay, and we haven't really covered this.
Can we wait? Can you write that down?
I just wrote it right there. Okay, go ahead, write. I've got a lot to cover in this last half hour. You're making me a little nervous.
Making me a little nervous.
Touche.
not equal to when in the actual problem, like if you would say 80 instead of the 72, it would say 80 again, and it would say
We
no,
would
or
say, if it would, for us to use a not equal in this question, it would say, is this evidence that the proportion of smartphone users is different from 80% or is not 80%? Okay. Here we're asking, is it evidence that it's less than? All right.
okay, yeah.
Okay, so our conclusion. So what this says, right, our p-value is 0.0256. I don't know if I want to write everything out. Maybe I will.
Yeah.
But it's a lot to write out, okay? What this means, okay, is that if teachers, if 80% of teachers own smartphones, when I take a random sample of 95, what's the probability that I only get 72% or something more unusual? How often does that happen by random chance?
2%.
It happens 2.5% of the time. So the question is, do you think this sample we observed happened because of just the random chance of 2.5%? Or do you feel like maybe teachers don't own smartphones at 80%? Yeah, I know, it feels weird, huh? Okay. Alright, I'm gonna write the short conclusion first. Okay? So this is my conclusion. My p-value is small. Okay, my p-value is only 2.5%. I'm going to say my p-value is small. So I reject the null hypothesis. I reject the H0. I conclude that that less than 80% of teachers own smartphones. Do you want me to write the long conclusion as well?
Yeah.
Whatever is going to be on the quiz. Alright, this is the essential bit that you must know, and I will provide the explanation so you can better understand it.
You never write except, it's always I reject one or I do not reject the other.
Yeah, it's either I reject the null or I do not reject the null. We never say I accept.
But that's what it means.
Yeah. Yes. On the p-value, yeah, I'll get to all of this. This is why you guys are making me nervous, because I still have a lot more to explain here. Okay. All right. Oh gosh. All right. I'm gonna just write this really quickly, and you guys are gonna have to write it really quickly. Okay. The p-value equals 0.0256. That means, okay, if 80% of teachers own smartphones, and I take a sample of 95 teachers, I expect 80% of my sample to have smartphones. Only 72% had smartphones. Only 72% of my sample had smartphones. How often does that happen by random chance alone? 2.5% of the time. Write that down. Hurry, 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 hurry.
Done.
Good. Okay, more stuff. More stuff. Yay! All right. Definition of the p-value. The p-value is the probability of observing our data for something more extreme if we assumed the null hypothesis were true. So if we assume that 80% of teachers own smartphones, and I take a sample of 95 teachers, I expect 80% of my sample to own smartphones. Okay, what's our p-value? It's the probability of observing our data or something more extreme. Only 72%. My data shows that only 72% of my sample had smartphones. How often does that happen by random chance? Only 2.56% of the time. That's my p-value. My p-value is the probability that we get this sample or something more extreme if the null hypothesis were true, if 80% of teachers own smartphones. Is that okay? So, our conclusions. Okay? We pick an arbitrary value called alpha. Usually alpha is 5%. We pick an arbitrary line in the sand. We pick a value called alpha. Alright? Alpha looks like that. Like the letter A, but maybe like a fish. I don't know. Okay? It's called alpha. It's the Greek letter for A. Usually, alpha is usually 5%, 0.05. But you could choose alpha to be 10%. You can choose alpha to be 1%. Also be 0.10 or 0.01 or other values. When the p-value is smaller than alpha, we reject the null. Okay. When the p-value is greater than or equal to alpha, do not reject the null. Yes? Sure. Okay, right. One more topic. It's a bit of a doozy. hypothesis testing for proportions of two samples. Yay, two samples. Alright, I'm just going to tell you stuff. Alright, the null hypothesis, when you're doing two samples of two proportions, is always going to be P1 equals P2, which, or it can also, these are the same exact thing, P1 minus P2 equals 0. Okay, these two things, these two sentences say the exact same thing, right? This one says P1 equals P2. And then over here, we just subtracted P2 from both sides, and I have P1 minus P2 equals 0. These are saying these two numbers have the same value. This one says the difference between the two values is 0. Okay, they're saying the same thing. So get comfortable seeing things written this way or this way. Okay, but your null hypothesis is always going to be either this or this, and they're saying the exact same thing. The alternative will be P1 is greater than P2, or P1 is less than P2, or P1 doesn't equal P2. In which case, do you double your tail area?
Not equal.
This one. Okay, so this is the two tail. The other case, you leave your tail area to get your p-value. This one you double, right? Just same rules as before. Okay, or you rewrite them this way. P1 minus P2 is greater than 0. P1 minus P2 less than 0. P1 minus P2 doesn't equal 0. Okay, your z-score is going to be P1 hat minus P2 hat. Okay, technically there's a minus 0, but minus 0 means nothing, so you can ignore it. So sometimes you see the minus 0 ignored, divided by the standard error. Okay. Sometimes we call this value P1 hat minus P2 hat. Sometimes that's called the observed difference. Sometimes that thing is called the observed difference. P1 hat minus P2 hat. Alright, again notice, are there any hats in my hypotheses? No hats in the hypotheses. We have hats in our z, we have hats in our standard error. We're going to have hats in our standard error, okay? But notice, no hats in the hypotheses. Mess that up. Common mistake, putting hats in hypotheses. Okay. All right, you ready for this part? The standard error, it's an ugly formula. There's nothing we can do about it. It's an ugly formula, okay? I want to check the way it's written in the book, because I want to make sure I'm writing it the exact same way, because everybody, if it's not. Okay. P hat times 1 minus P hat times 1 over N1 plus 1 over N2. That's it. Okay? P hat times 1 minus P hat times the quantity 1 over N1 plus 1 over N2. Alright? But wait, there's more. P hat equals total success divided by total observed. Alright, or in other words, x1 plus x2 over n1 plus n2. Huh? And that's it, okay? No, hang on. Okay, and then you go through this just like the other problem. We will do an example together, and it will make sense when I do it. On the board, it'll make sense. Alright? It's just when you do your homework, can you do it then? And yes, you can. You can, alright? I believe in you. Okay. 2 samples, proportions. So we might ask a question, are there more blonde-haired women than blonde-haired men? Yes, no, maybe? Who knows? Alright, let's figure this out. Okay. Are there more blonde women than blonde men? Okay. We'll say in America. Okay, so let's go out and we collect data. Alright, so we have sample 1 and sample 2. Alright, which one is the men? We'll call sample 1 the women and sample 2 the men. How many women did we survey? Give me a... 500. That's too many. Okay, 120 women. And how many of them had blonde hair? No, that's too many.
42.
Okay, let's say 30. 30 of the women have blonde hair. So n equals 120 and 30 have blonde hair. So, okay, x equals 30, alright? Now, when you read a problem, it's not going to say n1 equals 120 and x1 equals this, alright? It's going to be written in a paragraph, and you got to figure this out. You're going to have like this problem on like smoking, quitting smoking with nicotine gum, alright? This follows this, alright? I'll start in your homework. The nicotine gum problem is a 2-sample proportion problem, alright? So when you get to that, figure this out. Okay, and the men, let's say we asked 100 men, and let's say 13 are blonde. I have no idea. Okay. So we want to know, is this evidence? Does this data provide evidence that there are more blonde-haired women than men? What do you think? Do you think there's more blonde-haired women than men, or they're the same, or not?
More blonde-haired. More.
Blonde-haired women. Okay.
But it depends.
Alright, is that okay?
I have a question.
Yeah. What's your question?
My question is, for the men, is it N2 equals 100?
Yeah, N2 equals 100 and X2 equals 13. Huh?
do it.
All right, so our null hypothesis would be what? P1 minus P2 equals 0. Okay, that's always going to be our null hypothesis. I could have written it as P1 equals P2, but I decided to write it this way. The alternative, P1 is our sample of women, P2 is our sample 1 is the women, sample 2 is the men. So P1 represents the women, and P2 represents the men. And the question says, does this provide evidence that there are more blonde women than blonde men? So this would, P1 minus P2 should be greater than 0. Okay. So far, so good. All right, so we want to figure out our z-score, our standard error. So to figure out our standard error, let's figure out p hat. What is p hat? Total success over total observed. Now, success is an arbitrary label. That's exactly right. Okay, so how many blonde people do we have total? We have 30 plus 13. We have a total of 43 blonde-haired people. How many people total? 120 plus 100? 220. So my p hat, I don't know, what's 43 divided by 220? I should have done 14. That would have been an easier number. But, okay. 43 divided by 220? 0.195?
Yeah.
Okay. I'm trusting you. Okay, so we have this. So I got p hat is 0.195. So what's my standard error? Standard error is p hat 0.195 times 1 minus 0.195 times 1 over n1. What's n1? 120 plus 1 over n2, 100. All right, let's do this. See if you can do this on your calculator. I get 0.0536.
On these kind of calculators, can you put everything in once? No.
Yes, you can.
Yay!
How do you put 1 over 20?
0.0536. Is that what we get? Do we get 0.0536, everybody?
Yes.
Great. Actually, with the rounding, I might get 0.0537, but that's okay, all right? Less of an issue. All right, so I've got that and I got that. So let's get my z-score. Okay, so z, you have a question. Wait. Yes.
I'm lost on the one.
Quiet. Go ahead.
I'm lost on the 1 over 120 plus 1 over 2 over 220.
Oh, and I just erased it. Okay, so this is p hat times 1 minus p hat.
Yeah, I got that.
And this is 1 over n1 plus 1 over n2.
I got like.
n1 is 120 and n2 is 100. So
I got that part.
yeah.
But then I didn't get that one.
You didn't get this.
Yeah.
All right. What kind of calculator are you using? That one. Okay. That should do it. All right. Okay. Detour for a calculator lesson. Okay.
My only question is for 1 over 120, I don't really understand fractions. So So is it
Oh,
2
okay.
over
So
220?
do it's 1 yeah, it's not 2 over 220.
Oh,
No,
okay.
find a common
That you right, you got to find least common denominator, which in this case I don't know what it is, 600. Okay, so you'd have 5 over 600 plus 6 over 600.
Okay.
You add those two together,
Okay.
11 over 600.
Alright.
Okay, or you could just enter it on your calculator. All right, calculator lesson for everybody. If you did not get that 0.1, you do 0.195 times button, parentheses. If your calculator has parentheses, 1 minus 0.195, close parentheses button. Okay, times button, parentheses buttons. Oh gosh. Yeah, parentheses. Okay, and then you do 1 divided by 120 plus 1 divided by 100, close parentheses, equal sign. Then you take the square root button, and the answer, okay, equals.
Okay.
That should do it. That should do it. Okay?
Yeah. I got it now.
Try it out.
But it doesn't matter if you do square root before, right?
Yeah. This you might have to switch depending on your calculator. Okay? Yeah. Oh, you could do the square root over the whole entire thing also. If you did parentheses over there.
Yeah.
And parentheses at the end. Okay? If you can keep track of everything, great.
Yeah.
All right. And you should get 0.0536. All right. We got to keep going. All right, is this okay? Yes. All right, so my z-score is p1 hat minus p2 hat minus 0 divided by the standard error. What is p1 hat?
0.195.
No. P hat is 0.195. What is p1 hat? P1 hat is the proportion of women with blonde hair. So what is that? 30 over 120. What is p2 hat? 13 over 100. Okay? And I divide this by my standard error. And I do minus 0. But what, okay, so here's an aside. What is my observed difference? Observed difference. What proportion of women have blonde hair? 30 divided by 120. 25% of women have blonde hair. What percentage of men have blonde hair according to our sample? 13%. We have a 12 percentage point difference. Is this a big difference or not? That's what we want to know. .25 minus 0.13 is 0.12. Okay, so this is 30 over 120 minus 13 over 100. Is that okay? So I get 0.12 as my observed difference divided by 0.0536. I get a z-score of 2.24.
We want to know if 12% is big. A big difference?
Yeah. All right, we're observing a 12 percentage point difference. We surveyed 120 women, 30 of them have blonde hair, 25%. 25% of women have blonde hair, according to our sample. When we surveyed the men, 13% of men had blonde hair. Okay? 25% versus 13%. That's a 12 percentage point difference. Is that a big difference or not? Okay? Right? If the null hypothesis were true, this says the difference between blonde-haired men and blonde-haired women should be 0. We're expecting a difference of 0. What we observed was a difference of 12%. Is that a big difference or not? Well, our z-score turns out to be 2.24 standard deviations or standard errors away from the mean. So what is my p-value?
0.9875.
Okay. So I do this, and I end up at 2.24, and the area is 0.9875 to the left. How much is to the right? 0.0125. This is my p-value. Okay, my tail is 0.0125. That is my p-value. Huh? Is that okay? No? I just looked up 2.24 in the z table. I got 0.9875. I did 1 minus that to get my tail, and I get 0.0125. All right. So if I use a alpha of 5%, is my p-value bigger or smaller than alpha? Smaller. Can I erase some of this stuff? Okay. So let's say use alpha equal to 5%. My p-value is equal to 0.0125. That means my p-value is less than alpha. So our conclusion is we reject the null hypothesis. And that means we have evidence that there are more blonde women than blonde men. Blonde-haired women than blonde men. Okay? And I think this is true in real life. Huh? Why? That's it. And that's it, yeah. Okay, and then so yeah, that's hypothesis tests for 2 sample proportions. And it's not too bad. It's not too bad. It seems crazy. You'll get used to it.